Hello students, welcome to today's lesson. We have been looking at the Form 3, Chapter 2, that is the topic called the mole or the mole concept. And specifically in the last lesson, we looked at the empirical formula and we saw how we get the empirical formula using the steps. So today, we are going to look at what we call the molecular formula. So what is molecular formula and what are the steps of getting or determining the molecular formula of compounds? So we begin by saying that the molecular formula might or might not be the same as the empirical formula for some compounds. So the empirical formula is not necessarily the same as the empirical formula, though at times the empirical formula is the same as the molecular formula. Then molecular formula, unlike the empirical formula, it shows the actual number of each kind of atoms present in a molecule of the compound. So the molecular formula shows the actual number. We said for empirical formula, it is not necessary that the actual number represented in that compound or in the empirical formula is the same number of atoms that compound have, but for the molecular formula shows the actual number of each kind of atom present in a molecule of that compound. If the empirical formula is known, then the molecular formula can be determined by this relationship here, where we say the mass of the empirical formula multiplied by a certain number will give us the molecular mass. So we have first to get the empirical formula just using the same steps we used in the previous lesson. Then from there we get the mass of the empirical formula. Then that is what we are going to multiply by a certain number to get the molecular mass. So if the molecular mass is given, it is very easy to get the molecular formula. Therefore, we say that the molecular mass is always a multiple of the empirical mass. So we multiply by a certain number the empirical mass to get the molecular mass. Hope that one is well understood so that we can now look at several examples here. So we start with example number 1. We are given a compound that contains 40% of carbon, 67% of 6.7% of hydrogen, and 53.3% of oxygen by mass. So we are told to find its molecular mass. We say the first thing is to find the empirical formula. So we have the procedure of finding the empirical formula, where we say the first thing is to convert these percentages into grams. So 40% will be the same as 40 grams, 6.7% will be 6.7 grams, and 53.3% will be the same as 53.3 grams. So that is the step number 1 to get the mass in grams. Then we move to the second step where we find the number of moles. So to determine the number of moles, we said we are getting the molar mass of every element that we have here. So we have carbon, which has a molar mass of 12, hydrogen 1 gram per mole, and oxygen has 16 grams per mole. So to calculate the number of moles, we are going to take each compound, divide the mass of each by its molar mass. So for carbon, we are taking 40 grams divided by the molar mass, which is 12 grams per mole, which gives us approximately 3.33 moles. For hydrogen, we take its mass is 6.7 grams, then its smaller mass is 1 grams per mole. So that one also gives us approximately 6.7 moles. Lastly, for oxygen, we take the mass, which is 53.3 grams, divide by its molar mass, which is 16 grams per mole, to give us 3.33 moles. So we have the moles of the three components. So the next step is to find the simplest whole number ratio. So how do we find this simplest whole number? We said we divide each mole by the smallest number of moles. So the smallest number of moles is 3.33 moles. That is for carbon and oxygen. So we divide all the moles by 3.33. So when we divide for that of carbon, it will give us a mole ratio of 1. That of hydrogen will give us approximately 2.001, which is, we can round it off to 2. Then oxygen, 3.33 divided by 3.33 will give us 1. So now we have our ratios for each element. So that is the ratio of 1 is to 2 is to 1. So now we can combine the symbols of these elements with the ratio, the whole number ratio, so that we can get our empirical formula. So the ratio 1 is to 2 is to 1 gives us the empirical formula of CH2O. So this is the empirical formula. So we are done with the first part. So now to get the molecular formula, we said we are multiplying by a certain number. The mass or the empirical mass multiplied by the same number, a certain number, will give us the molecular mass. And from the question, we have been given the molar mass of that compound, the actual compound, to be 90 grams per mole. So to get the molar mass of the empirical formula, we take the constituent elements, so that is carbon, hydrogen, and 2 hydrogens and 1 oxygen, then get the total mass of the three. So we have carbon with 12 plus 2 hydrogen to give us 1, and then 1 oxygen to give us 16. So the molar mass of the empirical mass will give us 30 grams per mole. Then to get the ratio now, or to get N, what we have here, we are going to equate the empirical formula or the empirical mass, that is into brackets, N, that is the multiple we want to get, should give us the molar mass of the actual compound, which is 90 grams per mole. So here we divide this by 30, divide here by 30. So N will give us 3. So if N is 3, to get the molecular formula, we divide by we multiply, that is, the empirical formula by the multiple which we have found to be 3. So we multiply the empirical formula CH2O by 3. So C times 3 will be C3, H2 multiplied by 3 will be H6, and O times 3 will be O3. Therefore, the molecular formula of this compound will be C3H6O3. So that is how we find the molecular formula of the compounds. Very easy. If you can find the empirical formula, it's just multiplying the empirical mass multiplied by a multiple N to give you the mass or the molar mass of the actual compound. So that will help you to get the N or the multiple N. So after getting the multiple N, multiply it by the empirical formula to give you the molecular formula. So that's the first example. We look at the next example, that is example 2. So here we have a compound containing 26% of nitrogen and 73.3% oxygen by mass. If the molar mass of the compound is 92 grams per mole, we are told to find its molecular formula. Very easy. So we start with the step 1. So we are finding the empirical formula first. So the first step, find the mass in grams. So convert the percentages to mass. So this is 26.7 grams and this is 73.3 grams. So step number 2, we convert the grams to moles. So how do we find the moles? Using the molar mass. So we are taking mass over molar mass. Mass of nitrogen we are given is 26.7 grams divided by its molar mass, which is 14. So that gives us 1.91 moles. Then for oxygen, its mass is 73.3 grams divided by 16 grams per mole, that is molar mass, which will give us approximately 4.58 moles. So we have the moles of nitrogen and that of oxygen. We move to step number 3. So step number 3 is usually to find the simplest whole number ratio of moles. And how do we do this? By dividing each value by the smallest number of moles. So for our case here, the smallest number of moles is 1.91 mole. So we divide everything by 1.91. So for nitrogen, we divide by 1.91, it would give us 1. Then oxygen, that is 4.58 moles divided by 1.91 moles to give us 2.4, approximately 2.4. So this one, we write it into whole number, that will be 1 and 2, we round off. So the empirical formula will be what? NO2. So the empirical formula is given by NO2 just by combining the symbol, chemical symbol for nitrogen, which is N, and that of oxygen, which is O, with the corresponding ratios, or whole number ratios, that is 1 and 2. So we get the empirical formula to be NO2. Now, having our empirical formula, we are going to determine the molecular formula using the molar mass. So the empirical formula gives us the empirical mass. So we are going to take the molar mass of nitrogen and 2 atoms of oxygen and combine or sum up their masses or their molar masses. So that will give us 14 plus 32. So 2 oxygen atoms, that is 16 times 2 to give us 32. So 14 plus 32 will give us 46 grams per mole. And since we know that the molar mass of the compound is 92 grams per mole, so now we are just going to take the empirical formula, multiply by a certain number n, should give us 92 grams per mole. So therefore, to get n, we are going to divide the left side by 46 and then the other side where we have 92, we divide by 46. So this gives us our n as 2. So if our n is 2, we multiply it by the empirical formula so that we can get the molecular formula. So we are going to take our empirical formula, which is NO2, multiply by 2. So that will give n times 2 is N2. Then 2 oxygen multiplied by 2 will give us 4 oxygen atoms. So the molecular formula of this compound is N2O4. As simple as that. So that was our example 2. Finally, we look at our example 3 here, where we have a certain hydrocarbon being burned completely in excess high oxygen. Remember what is a hydrocarbon? This is a compound containing hydrogen and carbon only. So it is being burnt in excess oxygen to give 5.28 grams of carbon dioxide and 2.16 grams of water is being formed as the products. So we know when we burn a hydrocarbon, we always get two products, that is carbon dioxide and water. So when this certain hydrocarbon, which we don't know, was burnt in excess oxygen, 5.28 grams of carbon dioxide and 2.16 grams of water were formed. If the molecular mass of the hydrocarbon is 84 grams, so we are given the molecular mass, determine the molecular formula of this compound. So here, remember, we are not given the reactants, but we are given the products. So we need to use the products to get the reactants, which will give us the empirical formula, leading us to the molecular formula. So now we are going to get the ratios of, using the products, we are going to get the ratios in which these products were formed. How? So we are going to start by the two products, that is carbon dioxide and water. Their formula mass, that is carbon and oxygen, has a formula mass of 44, and that of water is 18. That is 2 hydrogen is 2 plus 1 oxygen is 16, will give us 18. So the number of moles, we are just getting mass over the molar mass, or what now here we are calling the formula mass. That will be 5.28 divided by 44 to give us 0.12 moles. Then that of water, its mass is 2.16 grams divided by its mass, which is 18, its molar mass, which is 18, to give us 0.12. Then we can get the mole ratio by dividing by the smallest number of moles. So 0.12 divided by 0.12 for both cases will give us a mole ratio of 1:1. What does this mean? So this means that 1 mole of carbon dioxide and 1 mole of water were produced. So the products were produced in the ratio of 1:1. So using that, we can find the empirical formula by finding the mass of carbon in carbon dioxide and mass of hydrogen in water, right? So we are going to get the amount or the mass of carbon in carbon dioxide and the mass of hydrogen in water. So the next step, we are going to take the products, then find the mass of carbon in carbon dioxide. So to get the mass of carbon in carbon dioxide, we take the mass of carbon, which is 12, then divide by the total mass of carbon dioxide, which is 44. So 12 divided by 44 multiplied by the mass of this product, which is carbon dioxide, which we were given as 5.28. So 12 over 44 multiplied by 5.28 was giving a mass of 1.44 grams. So meaning the carbon in this carbon dioxide was 1.44 grams. Then come to water. We want to get the mass of hydrogen in this water here. So mass of hydrogen is 2. Molar mass of hydrogen is 2 out of the total mass of water, which is 18, multiplied by the mass of the water we are using here, which is 2.18. This one was giving us 0.24 grams, meaning the mass of hydrogen used in this water was 0.24 grams. So now having the two elements, we can get the moles So moles is simply mass over molar mass. So mass of carbon is 1.44 over its molar mass, which is 12, to give us 0.12. That of what hydrogen, the mass is 0.24, divided by its molar mass, which is 1 grams per mole, to give us 0.24. So again, get the mole ratio by dividing by the smallest number of moles, which is 0.12. So the mole ratio was 1:2. Therefore, we can get the empirical formula as that of carbon, which is C, corresponds to ratio 1, and hydrogen corresponds to ratio 2. So the empirical formula is CH2. Then to get the molecular formula, we equate the empirical formula multiplied by a certain number will give us the molecular mass. So the empirical mass, that is 12 for carbon plus 2 for hydrogen, 2 hydrogen atoms, was giving us 14, then times n, that is 14n, to give us 84. So n was 6. So now to get the molecular formula, we take the empirical formula, which is CH2 multiplied by 6. So the molecular formula of the compound will be C6, then H12. And that is the molecular formula of the compound that, or the compound or the hydrocarbon that was reacted or burnt in oxygen to give the products, that is carbon dioxide and water. So that's where we are going to stop. Marks the end of part 3. And remember, we are going to look at part 4, which is molar solutions. So till next time, goodbye.